Here, the new feature is the AI Advanced Analyst. So this is the AI Advanced Analyst, and you have a choice between the reasoning model, whether Gemini, Flash, or DeepSeek, or O3. And these are multi-step or sequential models created developed in Flowwise. So the backend is LangGraph. So the reasoning is done by either Flash in this case, or you can choose DeepSeek, or you can choose O3 Mini, and just confirm selection. And these are one or two other tests which are in the test. So the reasoning is done by these models and the execution is done by GPT-4o, and we'll talk about it more when we go into the agent orchestration. The AI agent tab it will share the analysis in a specific, it will share the analysis in a formatted manner along with your charts, whatever were requested or required as per analysis. And each of the analysis, advanced analyst also has an agent reasoning. So when you click on that agent reasoning, you will get a background step by step. What is the routing which has happened? The SQL queries which were prepared, who did what and what did not work, and the errors and so on. So it helps you to debug things. General analyst is without a reasoning model. It can take queries and execute it. Both of them are equipped with a database tool, including the tool for Python and statistical analysis. And then we have the logs here. These are the processing logs, very detailed logs. In case you want to see the raw JSON formats of responses and all, then this will be useful. Now let's look at how all you can connect. So here in the app, you can connect to any database. If you don't have a database, want a temporary database, you can create a temporary database for a day. This one requires a login. You can upload a file, and you can upload a file. During file upload, in case you don't have your own database, a temporary database will be created for you without requiring any login. You can export files from your existing database, working file as well as any other files. And in case you want to do a quick check, there is a sample option is there. Few files are kept with prompt, and this will get uploaded into if your database, or if you don't have a database, temporary database will be created on the fly without requiring login. Okay, now we will connect to my AWS data warehouse. So these are the credentials for it. I have given a CNAME redirect, and I will change the password later on. So I'll connect from here. I will say connect, and I will send these details send to AI agent. So now it is connecting. So now we are connected. AI analyst is also connected, and the advanced analyst is also connected. Model, we will continue with Google Gemini, Flash. Okay, so I will cancel this. I am saying that show tables. First of all, show me all the tables, and then for these two tables, I know the name tables. Show me 5 sample rows as well as the row counts. Sample rows from the table, bank unique 1 million. So this has got 1 million rows. And what kind of data does it have? It has got demographic data, some contact data, as well as response yes, no, and the cust ID. This is good for doing all kind of analysis, including response models. A transaction table has got a very simple table. Cust ID is there, transaction code is there, and transaction ID, transaction data amounts are there. Row count is how much? This is 10 million records, right? Okay, so now we will go ahead with the analysis. So I am saying that build an analytics modeling data mart. So I am asking it to first create a data mart for customer profiling and machine learning with 1 record per customer using the bank, customer, and transaction data. This is a fairly small prompt. Okay, here we go. So we got the result. So this took around 3 minutes. 3-4 minutes. The time varies, time of the day also. Result, it has created this intermediate table, it has created this final data mart, and it has created data quality check, no mistake, cust ID found. So these are the derived variable it created: total count, total transaction, cash and retail counts, totals, averages, maximums, average transaction value, average transaction amount, last transaction, this thing, recency also. Recommendations now for modeling, you can use this for building a machine learning model. Now let's look at the reasoning process here. Same way the reasoning process, it went to router agent sent it to advanced analyst, which is Gemini Flash, which created a whole plan, understand the data. Feature engineering. So it did a feature engineering with the transaction data, including recency, frequency, monetary value, and the ratio of retail to cash. Then it did the data aggregation. Then join the table, then you create a data mart. So this is the plan. It is supposed to create a detailed methodology and plan, and then create the queries for it, which it created here. This query create table customer transaction summary as so and so here. It goes here, and then it goes here, and data marts creation. Then it goes to agent executor, which is supposed to validate the queries, double check it, and then run those queries. So I'll send this prompt out. The generate a customer profile summary report based on the customer data mart, providing an overview of customer characteristics, break it down by housing variable. Okay, so we are back. Now what happened? We ran this and we say, sorry, I encountered an error. So the query bombed out. Now I have deliberately kept this, because all the time everything doesn't go smooth, as you create the agent orchestration, these are things you need to manage. Yeah, so when I saw that error, I had two choices. One was, okay, just disregard that, delete that clip and re-record that whole piece, so that it's a nice and perfect view, or show live error debugging of that one. So that I am going to do that. So I'll show a live error debugging of that particular issue right towards the end. In the meanwhile, I had exactly same thing with same database, same prompts, another run in another session. So we'll take a look at the results there. I have this run from a previous run, exactly same with Google Gemini only. So I will show you how it actually did that analysis. I asked it to now generate a customer profile summary report, and it created a report. This is the customer profile summary report. Here it is sharing yes and no. This will amount to approximately 1 million. The blanks are there which it has missed out. So those are things which we can iterate. These numbers look okay, because these are numbers. Dummy data set only. I only created part of it. So these numbers are in sync. Average, this thing, cash and retail and so on. So we have the cash value and retail value and so on. The numbers look okay. And then it has created this set of charts. I don't like the charts pretty much, or there could be some issue in the chart rendering also. But essentially, even at a first iteration, even at a first iteration, it did a pretty decent job. So in the meantime, as I was checking that, I also ran one more with O3 Mini. So here I selected O3 Mini, ran exactly the same thing. This is a little better quality because this unknown 2400 blanks in housing, it captured it. Numbers are exactly same as in Gemini 1. If you just want to try out very quickly, then I have kept those same couple of files here in a sample, right? So this is sample file. These are small files. I have uploaded files up to 1.5 million 700 MB. This is for very quick test. This is a live data from RBI, Reserve Bank of India's monthly statistics on banks. Very rich data. So I will choose this. I will select, say I will want to select this data set, and I will say temporary database, right? So now it is doing an equivalent of a file upload. So it is uploading the file. It creates a temporary database, as you will see here. I have now chosen the model which I have chosen currently is Gemini Flash, right? We can choose any of this. So this is the default model, and we'll talk about the model in the later part of the videos. So I'll copy this prompt here and I'll send it. What I'm asking it to do is rank the top banks in the credit card segment using a scoring system. So I'm asking it to create a basic scoring system and develop a ranking methodology and then share the results. So it's a very small prompt. So Google came back with result, right? Analysis objective, methodology. It create derived variables, right? Average transaction value, average transaction value, total transaction value, transaction per card, value per card. Then it created a scoring system. So metrics were normalized, and we will see how it normalized it in a little bit. It normalized the matrices. It gave weightage. Then it did a ranking, and based on the ranking, it created the rankings based on this, and then additional insights, so and so. Visualization. It shared some charts here, which we can see this. Okay, now we want to see in detail what happened behind the scenes. So behind the scenes, what happened is we can click here to go into view agent reasoning. What did it do? It created all this system. It said that, okay, handle missing value, something, calculate these so and so ratios, right? And quick look of, I was taking a quick look just before this. So pretty decent ratios. Not that they have covered everything, but for a first iteration, keep in mind, this is one prompt, one iteration, 2 minutes. Then it created a scoring system that, number of credit card, transaction value, transaction per card, value per card. It created key matrices. Normalize the metrics. So it uses normalize each matrix using min-max scaling or Z-score classification. So we'll see what it actually did it. Then assign the weights, and this is the whole methodology. And then ranking. So this is the plan now. It has not been executed. So this is the plan, and it has shared the queries which need to be prepared. So it will be a bunch of queries which is shared, whole list of them, which then goes to the executor agent. So executor agent in this case is GPT-4o. So the GPT-4o, what it does is it starts executing the query one by one. Okay, now let's see how these agents, we have these 5 agents. These are all the sequential agents in Flowwise. Let's see how they are orchestrated, how they are set up. So they are all set up in Flowwise. So in Flowwise, they are set up in the agent flows, and all of them, this is how the flow looks like. This is with their tools and memories and other system, and I access them via API call. Flowwise, as I had shown in my previous videos as well as build guides, you can access them via API calls. Now for the agent structures, so I think it will be easier to look at a graph like this. So this is these are how these three agents, these three 1, 2, 3 Flash, DeepSeek, O3, the primary agents, this is how they are structured. So the request comes to a router agent. So the router agent will decide whether if it is a general request, if it's something which can be done by a general analyst, then it will send it to a general analyst. Otherwise, it will send to an advanced analyst. Otherwise to the advanced analyst here. General analyst will take care of all the regular queries, simple as well as medium complexity queries, and all the agents are equipped with database, two tools, database as well as Python. You can add some of my other agents. I have added web scraping as well as file updaters and so on, but in this case it is database and Python tool. Now here, if it is an advanced analysis request, then it goes to the advanced analyst LLM planner. This is not an agent, this is an LLM node. So API call is made. It does the reasoning part. It does the reasoning, and we will see some of the prompts now. All the prompts and then whole schemas are shared flow wise. All the schema and all JSON schemas I have shared. So everything details are there. You can just import it. It gets replicated. You just have to change the fast API endpoint. Now reasoning based, their job is to create a reasoning based analysis plan, and share the SQL query. And you have the option between DeepSeek, Flash, and O3 Mini. Then that goes to executor agent, which is typically GPT-4o. Or those three cases, GPT-4o, its job is to review, correct, execute the query in case of error, debug it, and share the final analysis and charts. One interesting thing which I found is that as a general analyst, GPT-4o Mini works exceedingly well. It works exceedingly well. And that's why I had first tried out GPT-4o Mini as an executor. But in this just executor role, when it is getting the whole plan, large big plan from our reasoning based agent, which can have 1, 2, 3, 4, 5, 6 queries. Currently, I have put a limit of 3 queries, and some of them are fairly complex queries. There it seems to falter. There this not there GPT-4 is working best, right? So that is the main agent, and the prompts and all I have shared in the code bases, and in the code base, the full prompt list I have shared there. They are also part of the JSON schemas. But their prompt, or rather the system instructions, system rather than prompt, system instructions. So router instruction, this is the instruction for router agent, giving it a background of who does what and how it can figure out who to send it to. Default is general analyst, and in so and so cases you send it to the advanced analyst, and I have found it to do a pretty decent job of it. This took some fine tuning, a lot of errors were happening, so all these prompts were after a little bit of fine tuning. Then the planner agent, so these are the things required, these are the instructions for the planner agent: analyze the question, reason, provide so and so. And then the reviewer plus execution. So reviewer plus execution, the GPT-4o, its basic responsibility is to review the SQL query first for correctness issues. And there are common mistakes it does, division by 0, and some of the things I have put there. That these are things which have helped reduce the errors, right? Then next is to execute that query visualization and share the report. I told them that whenever it does any kind of an analysis, it has to share a report in this format, header and so on and so forth. Add some recommendation. Always make sure to add some charts and so on, right? Now that is about these three ones. Now these two are under testing. These two are under testing. Here what happens is I am having the GPT-4o is pretty good at actually debugging and correcting errors, and it has a high error. Earlier I tried with GPT-4o Mini, but then a lot of error were happening as an executor agent, which immediately reduced as soon as I put GPT-4o. There is slightly higher cost. GPT-4o Mini cost is like, I don't even count it, very low. GPT-4o has got a bit of a cost, and we'll talk about cost and the performance issues in the next section. So this one. Now, in order for more review and more quality control and validation and so on, I'm trying out this model where the advanced, there are executor agent and there's an error corrector agent, which is both of them are GPT-4o Mini. This will kick in. This guy's job is only to check the previous conversation at the execution. If there is an error, then only his only job is, if there's an error, only then you review and re-execute. So under testing, I am still getting very good results, decent results with this, and we'll talk about the common kind of errors also, common errors and what we can do about it. Then this is a third setup which I am trying out. We have this is the existing setup, and then I am having an error debugger agent. So the objective of the error debugger agent is that this, in case there is an error, I find an error in the log, or I find that I would like it to be reviewed or error corrected, debugging is required, then instead of going through this whole loop, because this is a time taking loop, by the way, it takes anywhere from 2 minutes to 15 minutes sometimes it takes. So then on my request or a user request, it will go to here. This is GPT-4o, only job is to fix the error and execute it, right? So these are the things. So okay, now let's look at overall performance issues, various angles of performance. I'm sharing my experiences across not just this reasoning model, but across the last year and a half of working with text to SQL and so on. So let's look at the quality. So quality in the reasoning side of it, the highest quality on the reasoning side of it, I have found with Gemini to Flash 2 and DeepSeek. They are at same level, followed by O3 Mini. O3 I have not tested, I have not checked it out. That is for, I'm talking about reasoning. For all regular work, or the regular day-to-day work, I've seen again Anthropic is again higher quality, but here for reasoning I have not tested it out. Speed. Now in terms of speed, Gemini nowadays I'm getting much faster API responses from Gemini, or it is earlier it used to be very slow, a lot of API failures, but Gemini is good. OpenAI is very reliable. I will almost always get a response in the same amount of time across, very reliable, decent speed. DeepSeek is very unreliable. I think more than 50% time probably, or I don't know, fair amount of time the API call fails. When I check the site, it shows it's an outage happening. So I think it is an issue at their compute end. So hopefully it will get resolved. Reliability. The most reliable models, or I have not used Anthropic here, but Anthropic and OpenAI are the most reliable. The API calls will always get through. I will always get a response. There are some cases, this is analytics one-off thing, but there are some automation cases where I am making 100,000 API calls, then I cannot have a situation where 30% calls are failing. Right? That's the one. Gemini earlier was very unreliable, but very recently I am testing out the Gemini Flash 2. Even the experimental one was very unreliable. Flash 2 is looking pretty decent actually. And DeepSeek is currently, maybe because of their overload of their servers, it is not very reliable. Latencies, the time it takes, it depends whether I am using a reasoning node or whether the reasoning time or a general analyst. Reasoning times, for even simple queries like I showed you 1-2 prompts, it takes anywhere from 2 minutes to 10-15 minutes, or depending on many things. For a Gemini and O3, I will get the response in 2-3 minutes typically, but sometimes Gemini might also take 10 minutes also. For general analyst, typically, I will get a response in 30 seconds to up to 5 minutes. So depends on the complexity of the query. Sometimes the queries are a little complex, so it does take a couple of minutes. So this is something you have to keep in mind. What latencies you are okay with your use case, and based on that, the rest of the things has to be architected or structured, right? So that's one thing. Also, number of nodes will decide the latencies, right? The more the number of nodes you have here, the more the latencies will go up. So that is something that's an important point. It is easy to say that I will add a reviewer node and an error checker node, and I will have 3 error checkers, but suddenly your time is not no more. You are no more talking about 4 or 5 minutes. You are talking about 15-20 minutes sometimes, right? So you have to be. That's a trade-off. You have to see what is your actual use case that you are looking at. In your use case, you need a response in 5 seconds. That's a totally different architecture. The whole IT architecture there will be different, right? Time of day is an important one. I have seen that typically, especially for Gemini DeepSeek, I think, during US morning time, especially there is it's a slower. So this is also a factor. Agent backend, what I mean is, see, currently my API call, when I'm making an API call here, so if I'm making an API call from here, it comes from here, the API call, it comes here to my Flowise server. Flowise, again, there is a LangGraph which is being used, and there it goes forward. So I have got one hop, then one framework, the LangGraph framework, and then it goes forward. So it's also dependent on my Flowise server, which is on Hetzner, right? So versus there is always an option of coding the whole agent yourself at this level only, at this level or maybe one level, coding the whole agent here, and the API call, you can set up an agent directly here, and the API call is directly made from here, from your front end, or from a front end or a very nearby server, or via an API route, or whichever way. Direct API call, there is no platform, no LangGraph, nothing. You are just API call, and whatever looping and all you have to do, you are doing that looping inside with code. My sense is, there is one API call which I am using here, so it is much faster. So it's a simple API call. SQL errors, these are a couple of very common SQL errors. SQL failures are very common, especially in the complex reasoning ones. When you ask it to do advanced analysis, SQL errors are very common, and I was able to reduce it significantly, both in general analysis also and here also. Common errors are division by error. For some reason, it always gets confused with this division by zero error. You have to make sure that these are part of the system instruction. I will show it to you now. Overly complex query, you have to make sure that give instructions to keep the query simple, because more complex the query, the error increases. Order of execution, sometimes it makes an error quite often. Select star, I told you one error, right? I forgot to incorporate this. If you don't specify, it might do a select star something without a group by or without a proper where clause on some 10 million table, and everything is going to start downloading. Many of these things I have put as a part of the prompt, system prompt, part of the system prompt for the planner agent as well as the executor agent, division by zero, so and so. And for the planner agent, please be create avoid multiple SQL statement and nested queries. So these are things which you have to take care of either at a SQL at a agent system prompt state, or like I tell you, all these errors, whether it is SQL error, it is not necessary that everything will be managed by given a system prompt. Doesn't work that way. Many times it will simply ignore the system prompt. So depending on the type of error, you might have to have a second fallback catch, which could be at your database level, it could be at your fast API level, or you might be making another separate API call to a separate agent. So you have to keep in mind system prompts are not 100% reliable, but that is the nature of the beast, right? So based on the actual use case, you have to figure out the right levers, because there are trade-off involved. The more hops you put in between, your quality will increase, but the time will go up and so on. Database server schemas, and obviously your database speed and whether you have indexes or not, those kind of things. API call failure, I already spoke about. I have Anthropic and OpenAI very reliable. Gemini, now it seems to be, I have to check more. DeepSeek, I think, is still facing teething issues. Error catching and all this can be done at different levels. Keep it, like I just mentioned, depending on the kind of error, it could be caught at agent level, before agent level, front end level, your middleware, your fast API level, or at a database level with row level security. So keep that in mind. Sometimes you might need to have multiple levels. Validation. So this validation, what I mean is, any kind of analysis that you are doing, whether AI or no AI, doesn't make any difference. Validations are must. So when I am working on a real life problem, wherever doing some campaign file data cleaning or this thing, I'm always, me or most of us, we will always be validating at every step, what are the row counts, total, column, what are basically totals and the row counts at least. They should carry forward in the correct way. Merge, before merge, after merge, totals at the final stage. So those validation are absolutely must. You still need to carry. In the demos that I did, which I did just now, I was just running one query after the other query. That is not the way to, that was only for demo purpose. Otherwise, every query, then validate the number, then move ahead, then validate the number. Okay, now let's look at the costing. So we look at API pricing and my estimates of cost per query that I have been seeing. So API pricing, if you see the API pricing here on the OpenAI pricing page. So in terms of the basic API pricing, the O3 model is a little less expensive, roughly half of that of GPT-4o. So input price is 1.1 cents per million token, and the output is 4.4 cents per million token. GPT-4o is roughly twice of it, right? $2.5 per million input token, and output is $10 per million token. GPT-4o mini is the cheapest one, most lowest cost. It is just 15 cents per million tokens, and output is 60 cents per million token. Actually, the cheapest now is Gemini Flash. Gemini Flash 2. It is giving a performance equivalent or better than O3, and they have priced it lower than GPT-4o mini, and we'll see just now. So 60 cents per million token. And if we see Gemini pricing here, Gemini has a huge, not a huge, but I'll say very generous free tier, 15 requests per minute, 1 million token per minute, and 1,500 requests per day, which is very generous. This is good enough for, definitely for testing. It is good enough for, small scale testing as well as small scale use cases. Not for enterprise level, obviously. Then this pricing will come into play. So there they have a rate limit is there, and the pricing is lower. Keep in mind, Flash 2 pricing is lower than that of 4o mini also. So input pricing there mini 15 cents per million token, here only 10 cents per million token. Output pricing, there it was O3 mini 60 cents per million token, and here it is only 40 cents per million token, and the performance is at par or better than O3. So it's a very solid thing. The only trade-off is, till now I was getting a lot of API errors with Gemini, Google Gemini. There were a lot of unreliability. Two things, the API errors were there, and the answers, the responses sometimes will not be the ones that I wanted, especially for structured output. I was getting a lot of issues, and sometimes the jumbled answers will come and out. So now Gemini 2 Flash, whatever I have been checking it out in the last, it released what I think 10 days back, right? 2 weeks back, 7 days back. So so far pretty good experience there. And then we have DeepSeek. DeepSeek has priced itself a little. DeepSeek R1 has priced itself a little lower than O3 Mini. So O3 Mini, input token is $1.1 per million. Here it is 80 cents per million, and the output token is there it was 4.4, right? Here is $2.5 per million output tokens. Right? Anthropic, I have not tested it out in this scenario. I have not tested it. I have not tested it out, but for many of my other regular use cases, I use Anthropic also, Haiku or Sonnet. Now let's look at, to get a feel, how much does it actually cost per query, right? This cost per query, how much will it cost per query? So this general analyst, typically I am using GPT-4o Mini. This is like a workhorse. The cost is so low actually that even for my live use cases and all, many queries, then it goes up by, the billing goes up by $1, 1 cent. 1 cent gets minus. So it is this is a workhorse, a huge amount of thing. I typically start with GPT-4o Mini. If it can get me the result which I read, I stick to GPT-4o Mini. If not, then I will then move on to either GPT-4o or a Claude Sonnet. So this is like many queries, many queries will cost you 1 cent. Router agent is again GPT-4o Mini, not much. Now in this one, executor agent. Now executor agent here in this framework, executor agent everywhere I have kept GPT-4o, because GPT-4o Mini as an executor agent was not working very well, but as a general analyst it is working very well. So GPT-4o Mini here for every query. Now I am taking a benchmark. If you remember, I had in a demo, I had taken a simple this one. Yeah, so to take a cost per query, so depends on the kind of complexity of the query and many of those things, how many prompts and so on. But a single prompt, I had given an example of this file, and then only a single prompt, and then it came back with an answer. The file size by itself doesn't have a bearing, right? Just keep in mind, because file size by itself, it can have a. I have tested it out with the 64 rows table as well as my backend table, where it was 1 million to 10 million transaction table at 10 million, because the database query is run there, right? It is only this, these are the amount, the agent reasoning, these are the tokens that get counted, and whatever intermediate tokens they are counting at their end. So this kind of a query where you get this kind of a response, and this system prompt, depends on whatever I am asking for output also. This one will cost me around, I have seen GPT-4o go anywhere from 2 to 5 cents. So it varies. I don't know why it is varying so much, but in my mind I take it as 5 cents per query, or 2-3 cents per query, plus the cost of the reasoning model. Now, as far as reasoning model is concerned, Gemini Flash 2, there is no cost, because I am within the free tier limit. There is no cost there. O3 Mini will cost me, for that single kind of a prompt, it will cost me around 7 to 10 cents, and DeepSeek will cost me somewhere around just 2 cents maybe, right? So this is not in proportion of this pricing, by the way. Keep in mind, this may not be in proportion to the pricing that we saw here, because the way that they might be calculating their intermediate runs and so on. So in general, the benchmark I have in mind, and this is based on probably 100-200 tests, where testing 100 times, 200 times I would have done it. So this is costing me so less that I don't really count it. And I don't really count this, but at the enterprise level, if you are going to be doing 10,000 queries in a day, then of course in my real life use cases I do a separate costing and then share it. That depends on their use cases. Now here I take it cost per query for me in my benchmark, which I take, that if I use GPT-4o, if I'm using Gemini, it will cost me 5 cents per query. If I'm using O3 Mini, it will cost me around 15 cents per query. If I'm using DeepSeek, it will cost me around 7 cents per query. So that's a very rough, just to give you a broad idea. It is dependent on many factors, number of prompts, complexity of the query, how many queries I am requesting here, reasoning, I am requesting it 3 queries. Earlier when I was asking it to give me 5 queries, the costs were higher, right? But I think that might give you a little idea. I wanted to give you some basic back of the envelope calculations. Okay, so we are back. Now what happened? We ran this and we say, sorry, I encountered an error. So the query bombed out. Now I have deliberately kept this because all the time everything doesn't go smooth, as I was, as you create the agent orchestration, these are things you need to manage. So what I will do is, or what I did just before this, I check the logs. So first thing I will do is check the logs, what happened, where did it bomb out. So here it is showing me, so I went through whole of the logs, but here it is showing me in this session ID, error, the error is, I am getting an error from the chat flow build, which is flowwise, which is the agent. Why? Expected a string with maximum length 1 million. So Gemini has got, I think, whatever, I think 2 million, 1 million record, but got a string of 4 million. How does that happen? So when does this happen? This happens when you by chance do a full select query without group by or without where or something, right? Let's see. So I'll go one level back. I will go to my database server, fast API database server logs. So that server logs are, so I'll go, so these are my server logs, right? This is where all the queries are logged in. So I copied this query, and what I did was I copied this query, and it is difficult to human, it's not human readable very easy, right? So I copied this query and I gave it to GPT-4 that, please take the server logs and pull out the actual SQL query so I can monitor it. So now I'm looking at the actual SQL query. So I have already reviewed this. So while reviewing it, all the queries are fine. It is going about it in the right manner. But here is what, this is the offending piece. Select housing from customer data mart where uh, total transaction amount is not null. So this is going to get where they have used the where clause, but I still have around 300,000 record or something which is not null in transactions. So it has pulled. It's like equivalent of pulling 300,000 record. We don't want to pull that kind of thing, right? So that's why it bombed out. What is the lesson here? So this is the lesson here. So this is a gap in the agent orchestration, which I will now need to correct. It was there in my to-do list, but I forgot. And now this happens. I need to put in checks and balances across different levels, that any point in time, a full star select star or that kind of a query should not go through, or any query which has a record length of more than 10,000 record or 5,000 record should not go through, and that check can be done across multiple levels. So I can add that as a system prompt. Then I need to add a fallback. I will need to add a fallback at a fast API server, level also before the query is execution. But that will need either it will need a Python regex, or it will need a set API call there, and also at a database level. So database level, I think Postgres has some way of doing it. So database level I need to figure out, but that checks and balances, those controls will need to be that kind of a limit is required to avoid this kind of situation, and we will need more than one measure, so that if a system prompt is overridden, or if the system prompt is also overridden, then I have second or third level. There are 2-3 levels where it will be caught. Okay, so now as an immediate solution, these are the system prompts for various agents. So as an immediate solution, I have added that limit clause for all the agent whoever are involved, planner, executor, and so on, to always include a limit clause, and by default use a limit clause of 100 unless a smaller number is explicitly required for ranking or other purposes. So this can be modified depending upon the use case. So there are 6 flowwise, app is supported by 6 flowwise agents. So I have updated that. So there you have to update, or I have currently updated that, but you update that in all the LLM node system prompts everywhere. Updated schemas I have shared in the GitHub repo. Now, in addition, at a later point in time, I will also like to. This is the code. This is the fast API middleware code which establishes the connection. This is the endpoint where the query comes for file uploads and connections. This is the endpoint where it comes, and then the query is executed here. So at this point in time, at least. Planning to make sense to have some kind of a checkpoint also, like I mentioned earlier, at this point in time, which will check for select queries, and if it has a limit clause or doesn't have a limit clause, and depending on that, you return it back with an error to the UI, or you inject the limit clause yourself, which could get a little complicated, but that's depends on the use case and so on. And again, at a database level, like I mentioned, something that I've been incorporating. Now this is how that architecture looks like. All the whites are or the whites are the servers which are controlled by me or deployed by me at my end, and greens are the outside one. So let's just jump into it, and all these in the next sections I will be going a walkthrough of all the fast API server codes and so on, and agent flows we have already seen. Now let's look at let's look at this scenario. So very first thing is the when somebody does a connect, when you do a connect and we do a send to AI, then what happens at that point in time, that that go API call is made to agents, and all these arrows are denoting API calls, and the arrows, actually there should be an arrow from the other side also, because there is a request and there is a response, but it will become cluttered, so I have just kept it a single arrow. So these are all API calls at the server. So from my front end, API call is made to one of the API agent with the database credentials which are just dumped. So what the agent does, it parses the credential intelligently, and then it tries to establish a connection. So it sends out a SQL query string using the custom database tool, which connects to my database server. This is a fast API server, again custom fast API server, which connects to and executes the query on the database end, and the response then comes back. And once the connection is established, then the agent gets back with a response saying that I have established the connection, everything is working fine, something like this, right? I have tested the connection and everything is fine, here are the schemas. Same thing, what happens is, in case you send out a query, it again follows the same path. Follows the same path, and there is a fast API server which I have deployed on Coolify. So I have deployed my test servers, all my test and demo servers are deployed on Coolify, which is like a Heroku render. This is like a Heroku render clone itself, and this is installed on a Hetzner. So this is for my test and demo apps, or some of the smaller apps. Live apps for my clients, they prefer to some of them deploy it on their own servers, or if I am managing that I stick to render or Railway. Now this is when it comes to all the fast API servers have a detailed logging. So this is when the database connection query is executed, database connection closed. So here you will also get the same logs depending on where you are putting it. So you can monitor all the logs in case something goes wrong at some point in time, like I had shown you the debug below. Then we have to figure out, we have to go to each point and look at the logs there. Now the next one is what happens is when you do a file upload, then again that file is sent to the database server. Now database server, when a file upload happens, in order to upload that into a table, first is you have to do a create table. To do a create table, you need the column names and the formats, right? Only then after that will you do an insert or a copy. So how do we get that? Because the files could be different. So then I make a API call. So here I make a API call to LLM, OpenAI. I make an API call to an LLM API, sharing the first 10 rows of the text file and requesting that please tell me the column names and the formats. Is it a number? Is it a number? Is it a text or a number or a day? The Postgres or MySQL schemas, depending on what database I am connecting to. Now this is call made to the OpenAI or Gemini. OpenAI, I'm making a call to OpenAI, but I make it via proxy server. So these are all servers are all reusable components, right? Wherever there is an app, I just plug that in. So this call could actually have been made directly from here to here, but I've just got used to making it. So I have a proxy server for making calls to OpenAI and other places. The main objective of this is that I do not, wherever I want to make a call to any OpenAI endpoint, I do not want to make it via here for security reasons. When I make a call from here, I can put an IP whitelist here. My API keys is, even in the environment variable, it is not exposed, right? So it is totally separate. Then I get the schema back. Once you get the schema back in a structured format, right? It is all structured output. The codes and all we'll do a walkthrough later on. I get in a JSON schema that is used to do a copy or an insert. For Postgres, I am doing a copy, and then it goes into database. Then the response comes back here, and then I make another call to API agent that here is the database details. Please, here are the database details. Please study it, and then the agent will get back with a response like this. I have studied the schema and the sample data, so I send some 10 rows. I also send them the file path in case they need to work later on. So they need to know the sample data and the path and the file name. So file name and file path are shared. and those file path is also displayed here. If you see, this is where the file path is displayed, and this is where the connection settings are displayed. So that is the flow for the now file upload. Then this data table schema, this is this data table schema, this is a one feature which is there in the app. If you upload a file, here and you go to quick and you give a table, so you will get a quick view here in this table, and for numeric variable you will get the stats. But the thing is, this could be this is HTML table, but before loading the table I need to know what are the column name and what are the formats. So same, I need to get the schema. So that schema, I make a direct call to OpenAI via this proxy server, get the schema back and display. That is then displayed in the HTML table. Numeric variables are given those stats table, and that way. Now I also have a Neon Connect server, and I'll be talking about, next section we'll be going into the repos also. So this is that time we'll go into more detail, but here this is used in two scenarios. One is when I'm using the on-the-fly database. If you remember on-the-fly database in the demos, if you are using the sample data, you have a choice to create on-the-fly database, no login required. Immediately database is created, Postgres, and data is uploaded. Or if you are doing a file upload, even there you get the same option, upload to a temporary database in case you don't have a database, no login is required. That goes to my Neon Connect. So I have a Neon Fast API server. It comes to the Neon Fast API server, which makes an API call to Neon, which I will show you in the next section, to get the database username and passwords, and then they are retrieved. Those passwords are then retrieved, and if you are using a file upload or a sample file, this happens in sequence. First this is database is created, that password is retrieved, and with Neon the beauty is the database is up in milliseconds. Immediately database is, I don't have to wait for it to spin up and everything. So these credentials are received back, and if the user has uploaded a file, I check for if the file is uploaded or not, and then this flow is executed. Then this flow is executed where this flow gets executed where the file along with the credentials are sent to the database server, and again it checks for the proxy, it checks for the schema, and this flow. So these flow happen in sequence. The temporary database, these things happen. They are happen in sequence, and then you will get a message, this file has been successfully uploaded, please check your AI tab, and like I showed, you will get a message. Again same thing, you will get a message like this. So that is what on-the-fly database, where on-the-fly database. Now temporary database, this is this temporary database. When you suppose you want a temporary database, you create on DB here. This initiates an auth process. Now in this case, what happens is, this is the exact same process that comes here. The only difference is here I am sharing the credentials in the UI in the front end actually. This is actually an experimental feature. I just wanted to see how auth works. So this is optional. You may not want to do it, or you can just let it go. But I'll give a quick idea. I just wanted to check how auth works. So in any case, I'm creating the Neon server without any login. And if you look into the console logs and logs, the credentials are actually stored in session storage. So it is available that way. Doesn't matter. Both are. This was anyway experimental thing. So anyway, so auth check is done, and if the auth check passes, then it goes to the Neon server. If the person is not logged in, and log in or create new account and so on, and then it goes here and the database is created, and the temporary credentials are then shown. If you are shown, this is a login, this is a user, this is your password, and you can log in with that, and you can on the fly, in case you are uploading a file, you can do that also. Now next is and then this is part of the auth flow, make.com make.com flow. Once this temporary database is uploaded, then what I do, once the credentials are received here, then I create I also already have the auth detail, right? The user who is logged in that session. So the user, the email ID and some details I take and I pass it on for my record keeping via a make.com flow, which comes to this webhook or this API endpoint here, which updates a Google Sheet, which looks like this, which looks something like this. This is actually one single long row, but it is wrapped up here. This is just for my information, that which user has a sort of a record keeping. In any case, I delete the data in 2 days, but this was part of an experimentation. In case I have to keep record, more efficient, robust way is to update these records in a backend database, but this was a shortcut thing. And PDF service, this is that, if you click on that generate button here, if you generate PDF button, then you get a PDF like this. So for that, I make an API call. This is not my server. There is an API endpoint, MD to PDF, Markdown to PDF. It converts Markdown to PDF. So just I make an API call there. I get a PDF back, which I serve it from here. This was wholly built with Cursor. Now the repository, it has got 4 main repository. This is the main repository, and this is the main repository, and it has got a step-by-step guide. So we will do a walkthrough here, but before, let me just show you, if you have to do it with Cursor, how you can do it. So if you are on Cursor or Windsurf, work the same way, right? So you are here, this is, go to Composer, make sure you have the agent open, and then here you just type out. Now I'm going to voice type, okay? So I don't type out, I just dictate. So Windows H or Command H will open the Windows native voice typing. Yeah, I have just git cloned this repository. This is brand new, fresh. I want to deploy it. Can you guide me step by step, one step at a time, please? So now Cursor will get, I could have added a README file, but it will search on its own. It found the README file, then it will read the, so then it thinks I need to clone the repository. So I will say that, I will say reject, I will say, so it is not required. So let's proceed with setting up the front end first. I'll help you with so and so npm install. I'll say yes. So it is now going to the right directory. It is doing the npm install, and then you will say accept. I'll say accept. So it is asking whether we want to set up a .env file and whether you like me to help. So I will say that let's just set up the environment variable with the .env example there, and then we will. I want to get this front end up, and then we will keep. I'll work on the backends. So it has created the .env file. So it is now npm run dev. It will be, we can do it in our directory, but it's doing it. So I'll say run command. I'll say accept. Localhost 5173. It has gone to localhost 5173. So I will check localhost. I'll follow the link here. So localhost 5173. So here is the app, right? In 2 minutes, the basic UI is up, right? Matter over. None of this will work now. None of this will work. Now you have to set up backends one at a time. Now, if you do something here and give a connection detail, you will get error. Give a connection detail here in the same this thing. So I will get an error. Why? Because none of the backend is set up. Now we set up the backend one by one and plug in. It's like, and plug those in one by one. Now what do we need to do? So now these are things we need to do now. One at a time. So installed all these things it has done. So this model configuration is there. So this depends. So if you have those 5, these are the 5 models which are shown here, right? These are the 5 models which are shown here. So for this, the JSON schemas are also, I have shared here that these are flow wise, right? So in the docs folder, you will find the JSON schemas for them are there. So these you need to then, go to flow wise, but you go to flowwise and just import the schema and make the changes. And we'll for now make the changes. You'll have to give one API endpoint, which I'll come to next. So you import the schemas, import the tools, and there is only one, if I remember correctly, only one API endpoint you have to change. This models configuration, what it is talking about is here. You might have some different model, or you might want to give a different model name. So here in this app, in source, config, and this endpoint, this is where I am keeping the description. What you see descriptions here, what you see here, this description, what is first line, second line description. So that is kept here. So based on where you might have 2 models, you might have 3 models, you might want to call it something different. So that is how you do it. The linkages and all, they are all linked to the environment variable. The endpoint is kept in the environment variable, which we'll cover. Now, what else is there? Now, update the .env file. So these are the various endpoints that you have to we have to do. But I will come to this. This is actually should be the a little last step, near the last step. So as we go ahead, we'll set up the backends, and then each of this an environment variable will be set up here. So fast API server. So we need to set up 3 fast API server. One is a LLM proxy server. So what is this LLM proxy server? Again, there is a, if you come here, this is the LLM proxy server. I have shared the GitHub repo. This again has its own guide, again has its own installation guide. And again, you can do the same thing. You can open cursor and have it guide you step by step on this one. But what does it do? It is required. This is the code for it. Very simple. This is a very short code. What it does is, whenever I need to make a call directly to OpenAI, where I am making a call to Flowise, it goes to Flowise. But where I am making a call to OpenAI like this, or I am making a call to Gemini or OpenRouter, wherever. So there I am making a call from here. So my front end, the UI will make a call here, and from here I will make a call to OpenAI or OpenRouter. Why then? Why am I doing it? This makes sure that my API key, which is here, OpenAI API key or Gemini API key, they are all in the backend. There is no way of it coming in the front end at all. So my open front for security purpose. So I am not worried about OpenAI key, because if I put it in the environment variable, keep in mind JavaScript React, the environment variable gets dropped into your console log network and all those tags, right? So now once you have done this, then you will get, once you have done this, you have to deploy it, right? You have to deploy this on render or wherever you want to do. You might want to look at some of my previous videos. I had done a 5-part series, very detailed into how to deploy and stuff like that. So then once you deploy it on render, you will get an API endpoint, or that is this API endpoint, RT endpoint. There will be something called RT endpoint here. Then second is the RexDB API server. So this is these are connected. So I am telling what API endpoint these relate to. So this is the main fast API server. Again, there is a separate repo for it, along with its own guide and the explanation of what is happening there. And again, same here, if you look at the code, if we go into the code for it, what is happening here, this is the main, this is the fast API server, which establishes the connectivity between your front end and the database. So I have so the query, SQL query comes here, the SQL query along with database string. So this is the endpoint, it comes here, connect or DB endpoint, along with that whole request. This is the SQL query string, host, database, everything comes here. And from here, this Python code establishes the connection with the database, sends out the query, executes the result, gets the result, and sends it back to whoever is making the API call. Now this has got many endpoints. I am typically using only 2 endpoints, but there are many endpoints for different purposes. There is an endpoint for doing a query, there is for upload, MySQL, Postgres. So I'm using a couple of these here. So that and the detailed explanation of those endpoint here. Again, to get started, you can simply ask cursor. Again, same thing. Please get me started. I want new repository. The way I showed you earlier for the main repo, it will help you install you. And so this will also, once you install it, you will also again get an API endpoint if you have on render or wherever. That API endpoint is this one. So you have to replace the value for this one. The Neon database management server is related to this. Will also give you one API endpoint once you deploy it. So this is the API endpoint. Now what does this do? Neon proxy, this API endpoint is basically, so all the temporary database that you see that we created, that I showed in the demo, right? Temporary database that is created on Neon. So Neon has an excellent, very excellent this thing. So it is created on Neon, right? Neon.tech. And it has got a great pricing also, free tier. Currently I'm on free tier. You get 5 GB, you can create some many databases on the fly, right? So with the API call, you are able to create a database within milliseconds. The database is ready. You get the credentials and you can directly upload a file there. So that is what all this feature that we saw here. When I say sample, or when I say when we pick this sample now, nothing will happen obviously, but this temporary database, when we pick up, this is created in Neon on the fly. Postgres database is created on the fly, and later on I delete it separately. It is a temporary one, so I don't give the credentials here. Even this one, create DB, this is also to provide the temporary DB facility. You can do the temporary DB in many different ways actually, but this is I found that to be the most easiest one. And what's happening in the Neon proxy database, it is a very small code. All that we are doing here is we are creating, there are two endpoints, so we are creating a neon database basically, and there will be another endpoint to get the role and user ID, I think inside this, or it's a separate endpoint. Okay, inside this only. So from inside this also, so this endpoint, from this endpoint, we make an API call to two of Neon's endpoint. One, this endpoint is to get the database, and then this endpoint is to create a database, and there is one more. Now this one is to get the password role. We get the role and then we get the password. So the whole credentials from here are passed on to the front end, to our user interface. So it is passed in on to the user interface here, and then the next steps happen from here. From here, it is sent to the AI agent, which will do a connection, check the connection, and the connection is okay. It will send a message here, and there is a file which is there. Then that file will be uploaded using the other RexDB, that first endpoint that we saw. So the file will be uploaded using that endpoint and this credentials. So it is like a pipeline, right? It works like there are multiple pipelines here. Then we have flow-wise agent flows. I already spoke about those. We have these 5 agent flows which are there. All the schemas are there. So you have to set up these things. You set up the tools, and in the tool, one API endpoint you have to change. It will be seen here. You know, once you open the tool, if you open that tool, so in this tool, if once you will have something like this on your this thing. So this API endpoint here, this one, right? So this is what you have to replace with your RexDB SQL data endpoint, and that's it. Remaining everything is same, nothing. I think as far as I think no other change is required for as is deployment. So this is agent flows. Then that JSON schemas are there. Auth0, this is optional. You know, I won't go into it. But what I have set it up here. If you want to create this one functionality requires a authentication or a Google login. So I was trying it out with auth0. So this allows you to create a temporary database where user will get a credentials. Otherwise, all the other temporary database, no auth is required. So if you want to activate this functionality, you know, and you want to do auth0, so that's a separate thing. So I won't go into it, but Cursor will be able to. I have set it up, so Cursor will be able to guide you. But essentially, you will need to set up your auth0 account and auth0, and you know you will need to get these two things. You will need domain and the client ID. These two are required. And there is one more endpoint, which is your make webhook. This is again optional. This is for that, you know, wherever somebody has creating a temporary database. So I would like to create a record of all the email ID so that I can track who has created, and you know, in case I need to delete it and so on. So that is what this is a make.com workflow. I have shared the blueprint and schema, and in my previous detailed video I have shown how to set up these make.com workflow. So make.com here, all that it does is that once a new the temporary database is created, then the login, the database name and the username is passed on here. So I have a record of it. This is a experimental feature. There is more efficient ways to directly keep a record in the database side, right? But so these are optional. This won't stumble the app, as we are not using it. You can just put something there, and app will still work as long as that functionality. So run the development server. You can run the development server, and then you have to just deploy in Vercel. You know, pretty much that's all that is there. Now let's move on to the next other piece. Next piece is, so how do these various functionalities work? Right? So part of it, you know, in the Rex 2 version, I have gone a little more detail into some of the functions that way. But I will tell you a more easier and straightforward idea. So, and by now you would have guessed it. You know, I'm going to say ask with Cursor, and that is for any new repo and all. That's how I go about it. Or even for my repo, when I opened this after 2 months, I just opened it, right? After 2 months, half the things I had forgotten. So I also use the same process. But in the front end is the main directory, and in the front end now I have refactored the code. So earlier it was one big app, 4,000 line app.tsx file. Now all the components I have separated. All and the services I have separated. These are the database things which are happening. These are schema analysis and all. Now, easiest way is, for example, you want to know what happens. You know, you want to understand. You know, when somebody presses that first connect and this one, when somebody happens this, so what happens? So we ask the composer agent again. I'm going to voice type it. I'm trying to understand this app. So in this app on the top there is one button called connect. So I want to trace the flow about how that connect button works. What happens after it clicks, and whole series of events from start to end. Can you help me? Can you help to trace that? So I have taken the agent one. Once you have the agent, because it will now need to search. So it will search the code base. So it is searching the code base. It is found the connect button. Now it is going through. Now it is tracing the flow, and this is how it has traced the flow. So if you look at this, so this is the whole flow, and this will tell you what is happening. Initial button location, the connect button is located, and so on. So database. This opens the database connect dialog. This dialog. This is the database connect dialog, right? Then what happens? Connection. The dialog has two main input fields. This you put this, you put this. Then when the send to AI agent button is clicked, this happens. Validation happens, process dialog happens, and backend handle quick connect happens. And if you click on it, it will show you the function what's happening there. This is in the database service. So step by step, it will walk you through. Excel does an excellent job. Like I told you, when I picked this up after last, I think I had updated this was in November. I just picked it up, a little while back when I picked it up. Half the things I had forgotten, so I had to trace the flows myself again, right? So you can debug this one by one, and any piece of this you want to delete it, you want to modify it, or you want to just pick this up and put into your app. This is how you can do. Very often I have to pick up some component from here and put into some other app. Then I will ask it, please share the whole. I will ask it, then please share detailed code and setup which I can pass on to my other AI coder, so it will share the whole thing. Okay, now there is one important source in case for the flow wise, which is Leon Van Zyle's tutorial. So this is what I rely on for my flow wise, the basic. This is where my all the learning, for learning flow wise. So definitely for flow wise, anywhere you are getting stuck, nobody explained flow wise better than Leon Van Zyle. And for cursor, this is a great source. You want to learn cursor and tricks, Volo build. There are many great videos on cursor, but Volo, I like Volo builds. He has built right from full stack application end to end on cursor. So that concludes the build section. Thank you for watching, and have fun.